Dear students, today we will discuss about integration using trigonometric substitution. If in the integral question we see a square plus x square, in such questions we use the substitution x equals a tan theta. Same way, if in the question we see a square minus x square, in such cases we put x is equal to a sine theta. And the third one is, if in the question we see x square minus a square, in such questions we substitute x is equal to a secant theta. Now let us solve a question. I have already written the question. Integrate using trigonometric substitution. Integral dx over square root of 4 plus x square. Let us solve this. Integral dx over square root of 4 plus x square can be written as integral dx over square root 4, we can write it as 2 square plus x square. We have already discussed that if we have a square plus x square appearing in the integral, in that case we have to substitute x is equal to a tan theta. Here we have 2 square plus x square. It means a is equal to 2. Therefore, for 2 square plus x square, we will use the substitution x is equal to a tan theta, and a is equal to 2. So we will substitute x as 2 tan theta. In this case, x is a function of theta, and hence we can differentiate x with respect to theta, and this will give us 2, and differentiation of tan theta with respect to theta is secant square theta. And we can say that dx is equal to 2 secant square theta d theta. This expression we will use in the integral in place of dx. Same way, 2 square plus x square square root is also appearing in the integral. This also let us evaluate. This will be equal to square root of 4 plus x square. X is equal to 2 tan theta. So x square will be equal to 4 tan square theta. This is equal to square root. Inside the square root we will take 4 as the common factor, and inside the bracket we get 1 plus tan square theta, and this gives us square root of 4. We know that 1 plus tan square theta is equal to secant square theta, and hence after taking the square root we get 2 secant theta. So we have evaluated dx as 2 secant square theta d theta and square root of 4 plus x square as 2 secant theta. So now let us substitute in the original integral. The original integral is integral dx over square root 4 plus x square. This will be equal to integral dx, that is 2 secant square theta d theta divided by square root 4 plus x square, that is equal to 2 secant theta. Two cancels with 2. Denominator is secant theta. In the numerator we have secant square theta. So secant theta will cancel 1 secant theta and 1 secant theta remains. So now we have integral of secant theta d theta, and we know that integral of secant theta with respect to theta is equal to ln modulus secant theta plus tan theta. And this will be equal to, we have substituted x as 2 tan theta, and this gives us that tan theta will be equal to x divided by 2. This value of tan theta we can put here. Still, we need to calculate the value of secant theta in terms of x. Let us draw a right angle triangle using our basic knowledge of trigonometry. Suppose this is theta and this is our right angle, and tan theta is equal to x over 2, and we know that tan theta means opposite side divided by the adjacent side. It means the opposite side will be equal to x and the adjacent side will be equal to 2. And using Pythagoras theorem, we can say that the hypotenuse will be square root of 2 square, that is 4, plus x square. And from here we can find secant theta. Secant theta will be equal to hypotenuse, that is square root of 4 plus x square, divided by the adjacent side, that is 2. Using these two values, we get ln modulus secant theta, that is square root 4 plus x square divided by 2, plus tan theta, that is x by 2. And because this is an indefinite integral, we have plus c, that is the constant of integration. And this is our final answer.